252 million years ago, Earth came closer to total biological collapse than at any other time in history. These layered cliffs in northern Russia are the physical remains of the event. Known as the Siberian Traps, they represent over 3 million cubic kilometers of erupted lava. This constant volcanic activity triggered a chain reaction of global warming and ocean acidification that pushed life to the brink. Roughly 90% of all species on Earth were wiped out. In the oceans, 96% of marine life disappeared, and on land, 70% of vertebrate animals vanished, causing the near-total collapse of the global food web. The survivors inherited an unrecognizable landscape where the previous biological hierarchies had been erased. For the next several million years, they would be tested by a planet that had essentially reset its most basic rules of survival. This new world was Pangea. All of Earth's land masses had merged into a single supercontinent, covering more than 130 million square kilometers. Because the interior was so distant from the coastline, the cooling influence of the oceans almost completely disappeared. Evidence of this environment survives in rock formations called red beds. These thick layers of oxidized red sandstone formed under intensely hot, arid conditions, showing that much of central Pangea was a permanent desert. The ancestors of the dinosaurs were small, marginal players in this landscape. The earliest known fossils, like Eoraptor from Argentina, reveal a creature only about a meter long that weighed less than 10 kilograms. These tiny, unimpressive reptiles were living in a planetary furnace dominated by larger predators. Their path to becoming the rulers of the Earth required them to survive a series of geological filters that would destroy their more powerful competitors. Pangea's climate was defined by instability, swinging between prolonged drought and sudden, intense heat. This volatility acted as an evolutionary filter, favoring any species that could move faster and survive on less. Early dinosaurs possessed several anatomical advantages that were well suited to this instability. Their respiratory systems likely featured primitive air sacs, a feature seen in modern birds, which allowed them to process oxygen more efficiently than other reptiles. They also developed a more efficient way to walk. While their competitors often had a sprawling stance, dinosaur ancestors evolved an upright posture with their legs positioned directly beneath the body. This posture drastically reduced the energy needed to move. It gave them a stamina advantage, allowing them to travel farther to find water and food while consuming less energy than the predators around them. While massive, dominant reptiles struggled to adapt to Pangea's fluctuating food supplies, the smaller, more efficient dinosaurs were slowly outlasting them. Because Pangea was a single, unified landmass, there were no oceans to block animal movement. This created an open corridor that stretched across the entire planet. Within just 15 million years of their appearance, dinosaurs had spread from what is now South America into Africa, Europe, and North America. Their descendants were able to claim new territory without ever crossing an ocean. This geographic spread acted as a biological insurance policy. Constant migration meant that populations stayed in contact, exchanging genetic material and strengthening the species across the continent. By scattering their populations across tens of millions of square kilometers, the dinosaur family tree became nearly impossible to wipe out. A disaster in one region couldn't reach the members of the group living thousands of kilometers away. Around 201 million years ago, a second geological catastrophe began. As Pangea started to experience tectonic stress, enormous fissures opened across the crust, releasing massive amounts of carbon dioxide into the atmosphere. The resulting Triassic-Jurassic extinction event wiped out 50% of all species. Crucially, it erased the large, crocodile-like predators that had previously dominated most land ecosystems. Dinosaurs were uniquely prepared for this crisis. The millions of years they spent adapting to Pangea's earlier unstable climates had already selected for traits like efficient movement and rapid growth, the exact tools needed to survive a global climate shock. The extinction of the dominant aerosaurs left the world's ecological niches vacant. Because dinosaur populations were already widespread across the supercontinent, they moved into these roles, eventually becoming the most numerous large vertebrates on land. As the age of dinosaurs began, the supercontinent that had protected them began to fail. Slow-moving currents deep in the Earth's mantle started pulling the land apart in a process called rifting. Massive rift valleys eventually filled with water, creating narrow seas that widened into impassable oceans. Pangea was fracturing into two separate masses, Laurasia in the north and Gondwana in the south. This physical separation cut off the ancient migration routes. The genetic exchange that had previously unified the dinosaur populations was gone, and the different groups were now trapped on their respective continents. The loss of their global insurance policy meant these separated populations had to evolve, according to the specific environmental pressures and resources of their new isolated territories. This geographic isolation triggered an unprecedented explosion of biodiversity. Because they could no longer interbreed across the whole planet, dinosaurs began to evolve into hundreds of radically different forms. In the southern continents, this path led to the titanosaurs, creatures like Argentinosaurus that reached lengths of 30 meters and masses of 70 tons, becoming the largest animals to ever walk on land. On the northern continents, the isolation favored different adaptations. This led to the development of heavily armored species like Ankylosaurus and the diverse family of horned ceratopsians. Pangea's unified landmass allowed early dinosaur lineages to establish a global presence. Its subsequent breakup provided the isolation that led to the distinct evolutionary paths we see in the fossil record. In the end, the story of dinosaur evolution was authored by the shifting geology beneath their feet. Their empire wasn't just a result of their own biology, but a reflection of a planet that spent millions of years tearing itself apart.